Hello everyone, this is Ravi Bari, lecturer at Department of Mathematics in PHCASC College of Arts, Science and Commerce, Rasaini. Today I am going to discuss about a very important topic, which is binomial distribution, and this topic is very useful for all the students who are pursuing bachelor's degree and who are in the first year. So this topic is a part of first year BCom, first year BSc IT, first year BSc CS and BSc, and also it is useful for finding the probability in many cases. So that's why I have chosen this topic. And now let's start what is binomial distribution. So before that, I will just discuss few things that are going to be very important for this lecture. The first one is random experiment. So if we have any kind of experiment which has finite number of outcomes and more than one outcomes, then we call that experiment as a random experiment. For example, suppose if you are tossing a coin, then we get two outcomes, head or tail. So this can be considered as a random experiment, and if we roll a dice, then we get 6 outcomes, either 1, 2, 3, 4 or 5 or 6. So this can also be considered as random experiment. And if we will make a set of all these outcomes, then we call that set as a sample space. So now suppose we have a random experiment which has only 2 outcomes, then that is a very special type of experiment, and we call that experiment as Bernoulli trial. Bernoulli trial is an experiment which has only 2 outcomes. So for example, if I am tossing a coin, then there are only 2 outcomes, head or tails. This is a Bernoulli trial. Now if I will roll a die, then there are total 6 outcomes possible. Therefore, it is not a Bernoulli trial. So Bernoulli trial is a random experiment which has only 2 outcomes. Now suppose, if you will see here, suppose if student is giving an exam, then there can only be 2 possibility. Either he or she will fail in exam or will pass in exam. So we can denote the outcome as fail and pass. So this also becomes a Bernoulli trial. And similarly, we can denote success by 1 and failure by 0. So this is also a Bernoulli trial. So a Bernoulli trial has only 2 outcomes. So one outcome can be considered as success and another outcome can be considered as failures. So we know that if we will add all the probabilities of all the outcomes, then it will be equal to 1. So suppose for the success we have probability 1, probability p, then for failure the probability will be 1 minus p. So this is the probability of success and this is probability of failure. Okay, so Bernoulli trial is a special type of random experiment which has only 2 outcomes. Now suppose if we take a Bernoulli trial and if we repeat it n times, then the question is what will be the probability of getting exactly x success. So for example, I am tossing coin 4 times and I want to know what is the probability of getting exactly 3 heads. Suppose if we consider head as a success, then we are interested in finding the probability of getting exactly 3 heads when I will toss coin 4 times. Now pay attention here that if I will toss a coin 1 time, then the outcome will be either head or tail. That means there are exactly 2 outcomes. So this trial can be considered as Bernoulli trial. Now if I will repeat this 4 times, then I am interested in finding what is the probability of getting exactly 3 heads. So such type of question can be solved by using the binomial distribution. So here I will give you the formula. Suppose there are n is a natural number, n Bernoulli trial and in each trial probability of getting success is P, then the probability of getting exactly X success is given by NCX P raised to X 1 minus P n minus X. So here this is binomial coefficients, or I will write the formula. This is NCR or NCX. It is computed as n factorial upon n minus x factorial into x factorial. This P is probability of getting success in each trial. Now this is a binomial distribution. Here probability of getting success will be constant in each trial, and 1 minus P. So here total probability is 1 and the probability of getting success is P. So the probability of getting failure will be 1 minus P. So n minus x. So this will be raised to 1 minus n minus x. So now we will see one problem based on this. You can pause the video and you can try this problem. Suppose a fair coin is tossed 6 times, then find the probability of getting exactly 4 heads. Okay, so again tossing a coin is a Bernoulli trial. We are repeating it 6 times. So here n is equal to 6. This is your n and this is your x, because we need exactly 4 success. And since it is given that the coin is fair and there are 2 outcomes, so each outcome will have probability 0.5 and 0.5, that is 1 by 2 and 1 by 2. So in this question the probability of getting success in each trial is 1 by 2, and similarly probability of getting failure is also equal to 1 by 2. So here we have x, we have n, we have p, we have 1 minus p. We can substitute these values in this equation to find the probability of getting exactly 4 success. So I want all the students to try this question, and in the next clip I am going to solve the solution. Okay, so now I will discuss the solution of this problem. So let's write all the required thing. So here we have n is equal to 6, x is equal to 4, p is equal to 1 by 2, 1 minus p is also equal to 1 by 2, and NCX, which is equal to 6C4. This you can compute. 6 factorial divided by 2 factorial into 4 factorial. So this is equal to 5 into 6 upon 2, which is equal to 15. So the probability of getting exactly 4 success is equal to 6C4 1 by 2 raised to 4, and 1 minus p is 1 by 2. So I will directly write 1 by 2 raised to, so n minus x, n is 6, x is 4, so n minus x is 2, and this is equal to, so 6C4 is 15 into 1 by 2 raised to 6, and if you will compute 1 by 2 raised to 6, 64. So this is the probability of getting exactly 4 success. Now I will discuss next variant of this question. So question can be asked, find the probability of getting at least 4 heads. At least 4 heads, that means at least 4 success. That means your value of x must be greater than or equal to 4. So this is the condition given, at least 4. So this we will denote like this: x is greater than equal to 4, and that means x is equal to 4, x is equal to 5, x is equal to 6. Now if you are tossing a coin, and if you are considering x as a success or head as a success, then there are only 6 success possible, because you are tossing coin 6 times, so you will get only 6 heads, right? That's why I have written x is equal to 6, x is equal to 5, x is equal to 4. Now in this, so this you can compute in this way, and similarly if you will replace x is equal to 4 by 5, you will get x is equal to 5, and similarly you can calculate x is equal to 6 to get the probability that x is greater than equal to 4 or x is at least 4. So this I want everyone to try. And the next variant is find the probability of getting at most 4 heads. That means your x is less than equal to 4, and in less than equal to you will get p of x is equal to 4 plus p of x is equal to 3 plus p of x is equal to 2 plus p of x is equal to 1, also p of x is equal to 0. Now why I have written p of x is equal to 0 is because suppose if you are tossing a coin, and in all these 6 tosses you are getting tail. So in this case your success is 0. You are not getting any head, that means the total number of heads is equal to 0. So this you have to consider. So this is for at most 4 heads. Now again x is equal to 4 you can compute in this way. For x is equal to 3 also you will have to calculate, and x is equal to 2, x is equal to 1, x is equal to 0 you can compute using this formula. Yeah, this formula you just have to replace x is equal to 4 by x is equal to 2, x is equal to 1, and x is equal to 0, and you write down these values, and if you will add all the values you will get the probability of getting at most 4 heads. Okay, now I will discuss the properties of binomial distribution. So here I will discuss mean and variance. So suppose we have a binomial distribution which has total n trials, binomial distribution with n trials, and suppose p is the probability of success in each trial, then the mean is given by the product of number of trials and the probability in each case. So NP is the mean, it is also denoted by the Greek letter mu, and variance is given by NP into 1 minus P. So this is number of trials, P is the probability of success in each case, and 1 minus P is the probability of failure in each case. So now I will discuss one problem based on this. So suppose we have a Bernoulli trial with 14 trials, and probability of success in each case is 1 by 4. Then the question can be asked, find the variance and mean. So here you can use the formula n into p and you can find the answer. So this is the mean of the given binomial distribution, and similarly the variance is equal to n into p into 1 minus p, which is equal to 14 into 1 by 4 into 3 by 4. So if 1 by 4 is the probability of success, then 1 minus p, that is equal to 3 by 4, will be the probability of failure, and if you will compute this you will get 14 by 16. So this is the variance of the given binomial distribution.